This lesson is about pedigrees. The first question we want to ask is, what is a pedigree? Well, a pedigree just tracks traits across generations, and it does it by using symbols. So why would we want to use a pedigree? Well, geneticists a lot of times use it because fruit flies have quick turnovers in their generations. Plants, you can confine all your plants. But if you're looking at a trait that's a human trait, it takes a long time for that person to grow up. Maybe or maybe they don't have children. So it's very difficult to track that trait over generations. So a lot of times you have to interview individuals and families to get a sense of the genetics of that family. We use symbols rather than names a lot of times to track these traits. Males are squares, females are circles. If the individual has the trait you're looking for, then that shape is colored in. A horizontal line means that they're married. A vertical line means that they have children. And then in this case, we have some daughters and sons. The daughters are circles, the sons are squares, and the little triangle shape means that there's a set of twins. Whenever we're marking these generations, the oldest generation we can find is a Roman numeral 1. And then every generation after that gets a different Roman numeral. So 2, 3, 4, as the generations progress. Now, there's several different types of traits we can look for on a pedigree. If it's an autosomal trait, that means it's on chromosome 1 through 22. It has to do with some body chromosome, autosomal. Sometimes there's sex-linked traits. Sex-linked traits are carried on the X or Y chromosome. XX for girl, XY for boy. So how do I know that it's an autosomal trait? Autosomal traits are carried on chromosomes 1 through 22, so they're not going to be more common in males, or they're not going to be more common in females. There's going to be a pretty even distribution between males and females. They're going to be pretty close. So these traits are pretty close in that distribution. How do I know if it's autosomal dominant or autosomal recessive? Well, dominant traits, if you look at rule number 1, a parent has a trait, then the child has the trait. So we know it's passed on each generation. If you look at rule number 2, if the parents do not have the trait, the child will not have the trait. So those are clues to recognize dominance. All right, so if a parent is recessive, and the other parent's recessive, well then, that's the only type of children they can have. So how do I know if it's autosomal recessive? Well, if you look at rule number 3, you'll notice that heterozygous parents can pass the trait on to their children. And if you look at rule number 4, the only way you get all the children with the trait is that the two parents have the trait. All right, so that would indicate an autosomal recessive trait. So take a look at this pedigree. Which is it? Well, the first thing I notice is that it's even between the squares and the circles. So it's not sex-linked. It's going to be autosomal. I also notice that it's in every generation, which leads me to believe it's autosomal dominant. Here's one that I notice is also equal between the males and females, but it skips generations, which indicates that it's probably autosomal recessive. Here's one that's the same between males and females, so it's autosomal, and that it shows up in every generation, so that's autosomal dominant. That little rule of thumb works most of the time. Sex-linked traits are way more common in either males or females. If the sex-linked trait is dominant, chances are it's more common in females. If the X-linked or sex-linked trait is recessive, well, it's more common in males. So here's an example of a sex-linked trait. You'll notice that it's only males that have it, which will make it a sex-linked, but it's recessive. I hope that helps you understand how to read pedigrees a little bit more intelligently.